So this selects memory space in basically K increments, and if it picks the address, the K that corresponds to these address drivers, then the low order (16 bytes) will get written. Low order 16 addresses correspond to the LED drivers. So out of that whole 1K section, only really 16 bytes are being used. Now, the one thing I'm not so much confused but concerned about is these memory devices have addresses 0 or address bits 0 through 9 connected to them, I do believe. Let me save this while I'm thinking. Save. Kill. Oh, right there's the data sheet. Oops. I think. Maybe not. So these chips have address bits 1 through 9 connected to them. And pin 8's an enable. All the enables were tied to each other, but I never really followed it back, I don't think. So what pin is enable? 1 in. Oh no, these were separate. I hit these pull-ups right here, and I thought they went to that chip, or one of these 2 chips. They go to this 32, which is an OR gate, U13, right? Yep. Yep, right there. And the second input on these OR gates had a cross card to where? I wonder if that's like address 10. Yeah, let's trace this because it's going to bother me otherwise. Oh, suck. $79.04. $79.04. Oh, this is just a hex inverter. Input, output, input, output, input, output. Why is the output? So So it's taking a signal in, inverting it, sending it out, inverting it again, sending it out. So this is the 10th bit. So I bet you that hooks back to address bit 10 on the processor, which is pin so A10 is pin 40. So if my assumption is correct, pin 40, which is right here, should go right to there. And it does. So now everything is in this address map that I know of on this card. So we have our LED column drivers, 1 through 12, the row driver, the tape port, the pen port, 2 EEPROMs, the expansion connector, which is probably the EEPROMs and the ADC and real-time clock are probably all mapped into the same 1K chunk of memory. Although there could have been multiples up there, but I haven't found them in this. RAM. The expansion, which selects this set of kit. So in 1K blocks, we have the 2 base EEPROMs, which makes sense because you probably start executing at all zeros. Then you have the expansion connector, which is probably actually the EEPROM space for this. Then above that you have RAM. The next K you have your expansion ports, which is the 12 LED column drivers, the LED row driver, the tape port, and the pen port. Above that you have your status LEDs. 1K dedicated to that was kind of a waste, but whatever. The UART and the keypad input. So I think I've totally mapped out the address space of this card now. Now, what chips have I not flipped through? I haven't fully used this chip or this chip, but I'm guessing this one's related to the oscillator circuit here. I've used this chip. He's the one of the 2 LED expanders. He's U11. Yeah. So bad news here is if I want to cut this down to make it thinner, I lose this chip. So that's kind of a bummer. Now, one thing I could do is just wire all of these latches directly back to the micro. It adds more wiring to the project, but it may let me get this shrunk down and overall be a better thing. I haven't really played with this chip. I haven't fully debugged or traced out the reset logic. I think everything else is pretty well understood. I want to look at this buffer and make sure there's no gate control hooked up on him. But yeah, I think that's about it for this guy. So now it's time to go get some food. I'm starving. And I'll start thinking about taking off a few more of these excess components. I'm thinking I'm going to get rid of U22, U13, because I want to tap in basically right there. I don't care about any of this stuff. It's a shame that this guy wasn't located up here someplace where it was out of the way. And then pull off what's left over here that's not really being used. Oh, I need a trace. How much time do I got? I got some time. Yeah, so there's an enable pin here which we don't know where it goes, and then the data pins on these other guys that I'd like to figure out quick. So let's go pull up this bus buffer. It's 240. So pin 1 and pin 19 are the gate drives for this chip. So pin 1 and 19. They are hooked together, but that's on the back. Oh, they're just... And it looks like they're just tied to power. Okay, maybe they're tied to ground. They're tied to ground. I misspoke, sorry. Is this ground up here? Boy, it totally looks like that's hooked to... Huh. Well, they're tied to ground, so you know that buffer is always enabled, repeating the data bus up to those chips. So if I poke on here and then go swipe at the data pins on these guys, yep, there you go. So the same data bus that went to the memory chips also goes to the bus repeater chip or line driver chip, which then feeds all these 232s or 273s. Sorry, 232. I got RS-232 in the brain today. So this 240 would be a good place to break in, you know, drive my microcontroller bus into this side of the 240 and then leave the structure for the 273s on the output of the 240 alone, because someone else smarter than I, or at least with more knowledge of bus structure, ringing, and SI to make this work, has already set up the termination and the drive structure from here out. And with all the parts I took off of here, I have not touched this part of the bus at all. That'd be these termination resistors out here, and, well, I take that back. I did touch the bus because I took this chip off. I don't think that'll be an issue, and even if it is, I can always just cut the traces to this chip where they meet into the rest of this bus. But either way, I think I'm going to tap in right there, and that will drive this bus. The other thing I need to check out, so this is the 240 driver, which is U17. And same thing up here, 240, U17. And this is the data bus. Now, I should sit down and figure out the order of the bits on this guy, so when I wire it out later, it's easier to map my bits around. But I'm gonna leave that for another day when I'm not quite so hungry and losing my train of thought. One thing I do want to find out is the enable pin on this 273, which is U31. U31. Now all these other enable pins are tied to each other and tied high, so they're always enabled. This one's the exception. He's not. So the question is, where does he go? He goes to this 74LS 122. So what is a 122? I think that's a pulse stretcher. Yes, it is a retriggerable monostable multivibrator. You know, it totally sounds like you just made that up, sort of like blinker fluid or muffler bearings, but there you go. What this thing really does is it's more or less just a fancy pulse stretcher. So this picture here describes it best. So you have a short little runt of a pulse coming in. It will stretch the pulse to a specific width and then let it drop. Now the fact that it's retriggerable means that you can, once you have one pulse coming in and you're still in this delay, if a second pulse comes in that time, it will stretch the end of the pulse out past where it would normally end. So you can have a bunch of little quick pulses, and then you can always guarantee that the output will not drop until a fixed time delay from the start of the last pulse. So good, if you're going to relate this to the real world, it'd be like you had a long hallway with a light switch only at one end. When you flip the switch on, it'd turn on the light, and when you flip it off, you want the light to go off, 2 minutes later, so it gives you enough time to travel down the hall and get out the door. Well, if you sit there and flip it on and off a bunch of times, this circuit would keep it on until the last 2 minutes after the last on pulse. Now, what's not shown here is all the timing is from the starting edge. If you left this pulse high, what it would do. Probably describes it somewhere in this table. Inputs, outputs. Well, there's multiple inputs and multiple outputs. Yeah, it doesn't really describe what would happen in that case. But in this case, it's probably taking a very fast pulse from the processor and stretching out long enough to be useful for the gate drive or the base drives for the transistors, because otherwise you probably have a really quick flash on your column drivers. So there is the pinout. So we're coming in the very last pin, which is Q. So that is the output from the circuit. Now, there's a couple RC type stuff on here, which is used to set the duration of the pulse. Doesn't show an application. Oh, doesn't have one. That's kind of odd. Usually they have a little picture of the chip in a circuit, so you have an example to work from. These 3 pins here are to set up the time delay on the basically flip-flop, output flip-flop. Now, there's a Q and a Q naught output, so they're just inverses of each other. And then on the input, you have a clear pin on pin 5, and 1, 2, 3, and 4 go through a little logic tree here and do the set end of the delay. So let's go find where 1, 2, 3, and 4 go to on that guy. Okay, here you can see some of the stuff that runs over to a cap and some of the other timing components. Now what I'm curious in is one, is that pin 1? Yeah, pin 1 goes to the end pin. That's a wee bit odd. 2, 3, and 4 are all hooked together.